I'm Angelo.
I'm Lee.
And I'm Jacob.
And we got Javi behind the camera. And throughout this semester, we were able to work with the Blind Community Center. And our group specifically found an interest in their gaming experience, more specifically bingo. And throughout our observations and interviews, we found that their bingo boards cause a few issues when they're not as efficient as we think they could be. And we thought of a few innovations that could actually improve their current design.
So currently with the bingo boards they have, they're over 30 years old and they're getting to the age that they can't be used anymore. Also, they use the old version of the bingo boards where they use chips to mark their place, and unfortunately for the blind members, it's quite challenging to find the chips and to remember where they need to put them. And most of the time, by the time they put the chip down, the caller is already on the next number. And this poses a problem for most of the members as they like to use 2 or 3 boards at the same time. So we devised a pretty simple solution to fix this problem.
Basically, what we did is we designed a 2x2 prototype, and we try to get rid of the chips. And we use this flexible chip number tiles instead, and it can rotate inside the board and keep flat using the magnet. And if the number is caught, the blind member can just simply push down the chips, and this stands for the number is already caught. And when the game is over, they just push top of the chips and make it flat again.
Right. The main affordance of this board is the individual rotating tiles, as you can see. We did this because now once the tile is rotating into the board, it communicates back to the user that the board or the number has already been called, and they no longer have to account for this tile.
Another affordance is that once the chips has already been pushed down, you can just simply reposition it by pushing the top of the chips like this, and then you can just make it reflect again.
So at the Blind Community Center, the number caller will say, for example, I-14, and when this number is called, each column corresponds to the letter as well as the number. So in the current bingo boards, they do not have anything on top indicating which column it is exactly, so we wanted to incorporate the mapping of each letter being written out on top of the column. So this would be B, this would be I, and so on. So our last signifier is actually very important. It is how each of these tiles rests a little bit lower than the surface of the rest of the board. So this helps our visually impaired users because they rely a lot more on their touch than obviously any of their other senses. So it helps indicate that they are feeling over a specific tile versus the rest of the board, and it helps them really differentiate between each number. This tied in with all of our other concepts of the mapping on the top of the board, the affordance of rotating into the board, all of these help aid in increasing this discoverability of our overall prototype.